Introduction to Chemistry 11. Chemistry 11 is one of the branches of science that we teach in high school. It's useful then to ask the first question, what is science? What do we mean when we say science? Unfortunately, when most people think of science, they think of a course they took in school, or maybe several courses they took in school. But in fact, that's not really what science is. Science is a method. It's a way of doing things. It's a way of investigating the universe around us. And a subcategory of science, then, is chemistry. So, what do we mean when we say chemistry? Well, chemistry is the branch of science that isn't physics or isn't biology. Physics deals with forces and velocities and vectors, where biology, of course, deals with anything that is alive or used to be alive. So what's left for chemistry? Well, chemistry actually branches out into physics and into biology. We have courses called biochem and physical chemistry. So chemistry then becomes a branch of science that deals with matter and energy, specifically how matter and energy interact. That whenever you change matter, it requires energy. Generally then, what is the process of science? We know what science is. It's a way of doing. So what is the doing? Well, the doing is called a scientific method. The scientific method is not the only way to investigate the world around us, but it does delineate the scientific way to do so. It doesn't mean it's better than any other method or worse than any other method for that matter. It is simply the scientific method. You'll find many different versions of the scientific method. I want to give you my version of it. The scientific method, first step is observe. When I observe a reaction between potassium permanganate and some reducing agent under acidic and basic and neutral conditions, I see three very different results. But is that all there is to observing? Well, no. To observe, I must use all of my five senses and any tools that might augment those observations. It's enough to say I see, but I see better with a microscope or a telescope. If I'm talking about the sense of smell, well, the human sense of smell is good, but it's not as good as a dog's. And in fact, we have many machines that can sniff far better than a human can sniff. So when a scientist says observe, what he really means is every possible way that I can get observational data from the surroundings, that's an observation. It could be touch or taste or a tool that helps me do so. It could be vision, or it could be some way to augment my vision, such as a microscope or a telescope. The second step in the scientific method is to try to look for patterns in those observations. Does the same thing happen every time, or is there something unusual, something different? Once I find a pattern, I see, every time I put permanganate with that sulfide ion, it goes to a clear colorless solution. Okay, that's a pattern I can now start to describe and use to predict. And that's the third step. The third step says, based on those patterns, which I based on my observations, what theory can I develop? And it sounds so simple. Come up with a theory. Well, when permanganate gets reduced, it turns clear colorless under acidic conditions. Yeah, but when it's under basic conditions, it turns green. And under neutral conditions, it goes brown and chunky. So how can my theory predict the next result? Well, describing a theory, actually putting a theory into English language, is far more difficult than most people think, because there are always exceptions. There are always ifs and what ifs and maybes. So I need to test that theory. And the proper way to test the theory is with a controlled experiment. That is, to use a control, something where you don't change any variable, and then change it over time and see what happens. When I look at my permanganate reacting under basic conditions, initially it turns green. But over time, it goes a little muddy and then turns brown. There's a pattern there, and it happens every time. But what's happening? I need a theory that can describe that and can describe future events of similar type. I need to test that theory. The fifth step in my scientific method is to evaluate the results of that experiment. The evaluation can be tricky because oftentimes we are so in love with our theory, our original theory, that we don't want it to change. But based on the results of any experiment, there's only three possibilities. Those results support my theory, and I accept my theory as it is. Sometimes those results are close to what the theory predicts, but not quite, and I need to alter my theory a little bit, that is, tweak my theory. Sometimes the results of my controlled experiment completely refute what I was expecting, what I predicted based on my theory. It demonstrates that the theory is wrong. And that's difficult. It's difficult to get rid of a wrong theory. But those are the options. Accept the theory, tweak the theory, or get rid of the theory. So the 5 steps of my scientific method must be: first, observe. Based on my observations, come up with some patterns. Based on those patterns, try to develop a theory, and then test it. Test that theory with a controlled experiment and evaluate your results honestly and unbiasedly. That's how science progresses. Honest interpretations of our data. Did it work or did it not work? So that's the process of science. Chemistry, then, is the branch of science that deals with matter and energy and how matter and energy interact. So my next question must be, what's energy? Well, energy is not matter. So it's anything that is not matter, but has the possibility or the ability to change matter. It can change matter. Not it will, but it can. It has the ability to do so. So therefore, what's matter? Matter is anything that has mass and occupies a volume. Well, that's a good junior science description. A good senior science description is matter is anything with a rest mass. That is, it still has mass when the object is at rest. Light does not qualify. Light has mass, photons have mass, but not when they're at rest, only when they're moving. So light is not matter, it's a form of energy. Matter is anything that has a rest mass and occupies space. When I say space, what I mean is 4-dimensional space-time that Einstein described. That is not just volume. Volume is length times width times height, 3-dimensional. Space is 4-dimensional. Length, width, height, and duration, that is time. Something that doesn't have any duration never existed. So matter must have a rest mass and must occupy space. These are the 2 broad categories of chemistry that we're going to deal with, and how matter and energy interact. Energy now can be subdivided into 2 very broad categories, and all types of energy are subcategories of these 2. The first is kinetic energy. Kinetic energy is the energy of motion. The second broad category of energy is potential energy. Potential energy is broadly described as the energy of position. But that's not enough. It's not just the energy of position, but it's where that position is. Potential energy should be described as the energy of position within a field. So now we have 2 categories of energy: kinetic, motion, and potential, position. What are the subcategories of kinetic energy? Well, for a chemist, we're looking at molecules. There are 3 different ways that molecules can move. That is the energy of motion for molecules. It can rotate, that is motion around an axis. It can vibrate, that is, it can move back and forth. or it can translate. It can move across the classroom or across the test tube. The motion relative to an axis really is saying a change in the orientation of the molecule. It's spinning. Vibrational energy is the motion of atoms relative to other atoms within the same molecule. They're moving back and forth. They're stretching bonds or they're compressing bonds. And translational energy then becomes the motion of a molecule relative to some fixed boundary, the beaker or the test tube or some fixed boundary of some sort. It's a change in the position in three-dimensional space. Those three together, added together, give my total of kinetic energy for any collection of particles. My kinetic energy, of course, relates directly to temperature. Potential energy is the energy of position within a field. A field is a region of space in which a force has some sort of influence. Well, in science, we have several forces that we're interested in. Gravity, electromagnetism, and nuclear. Most of the time in physics, when we talk about potential energy, it's gravitational potential energy. Well, that's not really of interest to a chemist. What we're interested in is the position of charges relative to other charges. That is, the position of a charged particle in an electric or in a magnetic field. Again, nuclear potential energy exists, but only at very short distances, and we'll leave that to the physicists. For a chemist, chemical potential energy is really the description of the position of electrons and protons relative to each other. In our next video, we will talk about the different kinds of matter.